Hello. So today we are going to look at lesson 111 in our Algebra 2 Trigonometry book, and it is called Solving Puzzles in Teams. Okay, so we got a few objectives today. The main objective for the lesson is students will be challenged to work together as a team to share mathematical ideas and to justify their strategies as they represent geometric objects and order a series of connected functions to create a desired output. The Common Core standards that will be looked at are the Common Core State Standards Skills to Maintain section. The mathematical practice we will be using is modeling with mathematics. So, the introduction says, welcome to Algebra 2. This first chapter will challenge you to use different problem-solving strategies. You'll also be introduced to different tools and resources that you can use throughout the course as you investigate new ideas, solve problems, and share mathematical ideas. So a lot of this first chapter is learning some introductory things that we're going to use throughout the course. Get used to some technology as a calculator and Desmos. We'll be learning some vocabulary, reviewing a few things, and learning about some resources we can use throughout the school year. Okay, so the first problem you'll be working with the people by your tables. So you should all have a piece of looped string or yarn at your table. And what you're going to do is you're going to work with the students at your table to make each of the shapes you see below out of a single loop of yarn provided by your teacher. You may make the shapes in any order, so you don't have to make the pyramid first. You can make the cube or the star. Doesn't matter. Okay. When you make one of the shapes successfully, you're going to call the teacher over to show off your accomplishment before moving on to the next shape. So you want to let your teacher verify that you have made each shape. Okay. So the rules are that everybody at your table has to be touching the string or yarn. So not one person can be only making it. It has to be a group effort. Okay. You cannot use tape or anything. For the first four, they're three-dimensional, so you need to have a height or depth to your shapes. They cannot be two-dimensional. The star, the 5-point star here, that is the two-dimensional object. So pause the video, try these out, and then when you are ready to move on, unpause and move on to the next problem. Okay. So the next problem, they're called function machines. This is problem 1-2. So you should have a set of 4 laminated function machines. They are listed below. So f of x is root x, g of x is the negative x minus 2 squared function, h of x is 2 to the x minus 7, and g of x, that should be k of x, sorry. So maybe we can make that k of x. Let's just say k of x there. K of x should be negative x over 2 minus 1. And so what you're going to do, there are 2 problems, and you're going to work at your table to get a specific output by putting the machines in a particular order so that one machine's output becomes the next machine's input. So if you look over here, say this is the function up here, this is the function f of x right here. Say I put in the f of x 100. Well, what would be the output if I put x into f of x? Well, I'm going to take the square root of x, which is in this case 100. So the square root of 100 is 10. So what the machine would spit out is 10. And so 10 becomes the new input for the next function, maybe is g of x. And we can continue working that out. My picture's in the way until I'm done down to the very bottom. Okay? So we're going to do that with a few of the problems here. We're going to work these out together. So again, we're going to next slide. So the first question is, in what order should you stack the machines so that when 6 is dropped into the first machine, and all of the 4 machines have had their effect, the last machine's output is 11. So once you try this out, pause the video. When you are done, unpause the video and check to make sure that you are correct. Okay, so the first machine, okay, so we're going to drop in a 6. So one thing we want to note is the machines again. So we got f of x is the square root of x. We got g of x is the negative x minus 2 squared function. We got h of x, that's 2 to the x minus 7. And k to the x is negative x over 2 minus 1. So first off, I want to eliminate some choices in terms of my order here. So I'm going to put a little order, go 1, 2, 3, 4. So I want the output at the end to be positive, okay? So I look at these problems, look at these function families, okay? I know f of x is a possibility to be last because when I take the square root of a number, it's positive. But g of x can't be last because no matter what I do, when you square any result, you get positive. And since I'm taking the negative of a positive, my answer will always be negative. So g of x cannot be last, okay? H of x, 2 to the x minus 7. Well, I know that's exponential. I know when I take a number, that's going to be humongous, okay? So I don't necessarily want h of x first, and I don't want it last because I don't want a huge number at the end, okay? And k of x, again, you're taking the difference of a number, taking a number, dividing it by 2, making it negative, and then negative 1. So k of x probably won't go last either. So, so instead of going last, let's try to go first. So I'm going to take g of x. I'm going to let it be first. Let's try that. So I'm going to take 6 first. So I want to figure out what g of 6 is. So my calculator, I'm going to get negative 6 minus 2 squared. Well, so let's do this. 6 minus 2 is 4. 4 squared is 16. Negative 16 is negative 16. So I put the 6 into g of x, I get negative 16. So that's negative. So I really need it to be positive. So I think the next best case is to put k of x next. So let's do k of x. So what I'm going to do is I'm going to take the result I just got for g of x and I'm going to plug it into the rule k of x. So I'm going to figure out what k of negative 16 is. So I get negative 16 over 2 minus 1. So let's see what that equals. Negative 16 over 2 is negative 8. A negative 8 is positive 8. Positive 8 minus 1 is 7. So that looks like that is working fine. Okay. So now we're going to take 7. And so think about it. I want 11 out. I have F and I haven't used F or H yet. Well, H isn't going to give me 11 out at the end. So I'm probably going to use H last and use K. I don't want to use H last. Sorry. I'm probably going to use f of x last because I can't take the square root of 7 a nice number. So that means I think I need to do h of x next. So again, let's see if this works out. So 7 is going to go in for h of x. I want to take h to 7. So I get 2 to the 7th minus 7. I'm going to get out my calculator. 2 to the 7th minus 7 gives me 121. And so now I want that to be what I plug into f. And so if I'm right, my last number should be 11. So f of 121 is the square root of 121, which is, I know, to be 11. So I want this to be the order for my first function grouping. Okay, so if you made a mistake, go back and fix it really quickly before you move on. Okay, so the last question we're going to do is part B. So it says, what order will result in a final output of 131,065 when the first input is 64? So again, pause this video, work this out with your table or on your own. Once you think you have an order, unpause it and see what you came up with. Okay, so again, I'm going to write out the functions on the side. You don't have to keep remembering them. So g of x was negative, whoops, x minus 2 squared. H of x is 2 to the x minus 7. K of x. Okay, so again, I have four functions. We're going to plug 64 into the first one. So I look at these, again, I think I'm going to need a really big number. So the ones that give me a really big number will be h of x. I'm pretty certain I'm going to use h of x last, okay? So 64, okay, when I look into these numbers, I'm going to try out f of x first because I believe that 64 squares really nicely. So I'm going to take f of 64, so it'll be the square root of 64, and that is 8. So 8's a good starting point. So now given 8, which one would I do next? Well, I think I'm going to use, so I've done f of x, I'm going to use h of x last, I got g and k, so it's kind of a toss. We kind of think about a few things, so remember, whenever I put anything into g of x, I'll get a negative output. If I get a negative output and then plug that into k of x, it should give me a positive number. And I only want to put in for h of x is input a positive number. So I'm pretty sure I'm going to go g of x next. That'll give me a negative. Then I take that negative result from 2, I plug into k of x, that should turn a positive, and hopefully that number I get for k of x, when I take 2 and raise it to that number, minus 7 gives me what I want. So now I'm going to take g and plug that in second. So g of 8, so it's going to be negative 8 minus 2 squared. Well, 8 minus 2 is 6. 6 squared is 36, so that's going to be negative 36. I'm going to plug that into k. So I get negative 36 over 2 minus 1. Well, negative 36 minus 2 is negative 13. Negative 13 is 13. 13 minus 1 is 12. So I'm hoping that when I take h of 12, that will give me what I want. So 2 to the 12th minus 7, that is in my calculator. 2 to the 12th power minus 7 gives me, not what I wanted. So we got to rethink that I made a mistake somewhere. So let's kind of go back through this. So we get square root of 64 is 8. I want the first input to be 64. So g of 8, so I'll use my calculator, negative parentheses, 8 minus 2 squared gives me negative 36, so that looks good. Now I do k of x, so I get negative 36 over 2 minus 1. Oh, that's where I went wrong. So this one isn't 12, this is 17. And so now let's replace this and this with 17. All right, let's see if that works. So 2 to the 17th minus 7, and that is 131,065. So that works out for me. So that is my order for the second problem. All right, so now the last thing we're going to look at is some kind of notes, just kind of review a few things. So in this book, oftentimes at the end of each lesson, there is a section called math notes. So we want to look at functions in particular. So I want to define what a function is. So what is a function? A function is a relationship between inputs and outputs where exactly one output is related to each input. So remember, inputs are really the x values in our functions, and the outputs are really the y. So another way to think about this is a function exists when I have a relationship between x's and y's where for every x value I plug in, there's only one possible y output. So let's do an example. Let's look at the function y equals x minus 2 squared. So when I make a table for this function, so a t-chart, xy table, when you plug negative 2 in, you get 16. Negative 1 gives you 9. 0 gives you 4. 1 gives you 1. 2 gives you 0. I give myself enough room, so I make another one over here. 3 gives you 1. 4 gives you 4. And 5 gives you 9. So you can see how, even though 9, 4, and 1 show up more than once, every input for x only has one possible number come out for y. That is the definition of a function. So if you look over and you graph this, okay, I'm going to kind of graph this function, sketch it, so we're going to plot some points. So when x is 0, y is 4. So this is 7, so 0, 4. We know when x is 2, y is 0. So there's 2, 0. We know 1, 1 exists. 3, 1, and we know this is 4. So this kind of makes a shape like this. We call that a parabola. And when you look at relationships as graphically, what you notice is that if I draw a line, vertical line at any point through this graph, a vertical line will only touch it once. That is called the vertical line test. So if you have a graph of a relationship where no matter where I draw a vertical line, those lines will only touch the graph in one spot, that makes it a function. But if you would have a vertical line, so say I have this graph here, this is a graph of a circle, you can clearly see that if I draw a vertical line, I can find a vertical line that touches the circle twice. So when a vertical line does that, that tells me that this relationship isn't a function because it fails the vertical line test. Over here with the parabola, however, it passes the vertical line test because every vertical line I draw only touches the graph once. So those are some things you want to remind ourselves about. Okay. The other thing we want to talk about is this idea of function notation. So we have this relationship. We have this notation f of x, okay? So we can use f of x equals instead of y equals. They are essentially the same exact thing. They can be replaced one for each other. But when we know a graph or relationship is a function, we like to use this notation to give that to define it as a function, okay? And so this means, so this is the f is the name of the function. So that is the name. And what it equals is called the rule. And so function f is defined by the rule it equals. And what I put into here is what I'm going to plug in for that rule to get the output, okay? So there's kind of a bunch of things going on there. Um, Other words that we'll describe later and talk about is domain and range. So domain and range have a lot to do with functions in this course. So we'll look at that in a later lesson. But we want to take a few minutes and look over that idea, okay? So your job tonight is to complete problems 1-3, 1-4, 1-5, 1-6, 1-7, 1-8, and 1-9. You should have that on a printout. And you will upload photographs or scans of that work to your Google Classroom, this Google Classroom page, or physically turn in the work to the shelf in the classroom by next Monday. Right, there'll be a video you can watch on this lesson, also located in Google Classroom, so please look at that. All right, hopefully this was useful and helped you out, and we'll see you in the homework video.